Hello, everyone. Thanks, Martin, for the introduction. Thanks, Dana. Yeah, indeed, this is Ivan from Italy. I'm doing my postdoc in software security at the University of Trento, and today I'm talking to you from the beautiful Italian Alps. Even though these days we are required to stay at home, unfortunately, I invite you to the virtual hike, to the short walk in the mountains. And in the meantime, I will tell you the story about developers' perception of software dependencies. Well, imagine we are on our way. So take your bags, jump on the board, and let's hit the road. While on the way, let me start with the story of the Equifax company. Equifax is one of the largest multinational consumer credit reporting agencies. It collects and sells credit and demographic data, like names, credit card details, driver licenses, social security numbers, etc. It's a large amount of sensitive personal data of more than 800 million people. A huge bait for hackers, isn't it? In 2017, indeed, Equifax announced a cybersecurity breach. Let's have a look at its timeline. On March 6, 2017, there was a vulnerability affecting Apache Struts library disclosed. The vulnerability was severe as it allowed remote command execution. Along with the vulnerability, at the same day, they were exploited and a fixed version of the library available. However, Equifax did not react on it. On May 13th, 72 days post-disclosure, hackers discovered the Equifax consumer complaint web portal used vulnerable Apache Struts dependency. And hackers were able to get access to the web server. So for the next 77 days, they managed to get to customers' data due to the absence of proper segmentation in the network. And they also discovered some admin passwords on the Equifax server stored in plain text. So after the breach discovery on the 29th of July, Equifax kept the breach secret for 40 days until the 7th of September, when they finally told to the world that the critical personal data of more than 145 million people were stolen due to a security vulnerability in a vulnerable dependency. Quite dramatic, very dramatic, isn't it? Well, in the meantime, we have arrived to our starting point, so let's start walking up to the mountain peaks. But coming back to dependencies, let's check what's changed since the time of the Equifax breach. So from the academic side, there is a lot of research going on. You see, I just typed vulnerable dependencies, and Google Scholar returned me about 130K results, 130K papers. From industry, there appeared a bunch of tools that allow us to check dependencies of our projects. GitHub Security Alerts service allows developers who maintain their projects at GitHub to check their dependencies. NPM has a built-in dependency checker and NPM audit. Eclipse Steady and PyUp are language-specific tools. They can be used for Java or Python. Snyk and SourceClear are multi-language dependency analysis tools. Well, that's quite a lot of options. But what about developers? Do they actually follow the suggested practices? Do they use the dependency management tools? To answer these questions, we carried out a study with 25 enterprise developers coming from 10 different countries: Italy, Germany, Russia, Vietnam, United Kingdom, Spain, the Netherlands, Croatia, Slovenia, and Lithuania. These developers are involved in development of desktop, mobile, web, and embedded applications. They work in large or small medium enterprises, lead user groups, and actively contribute or even lead large free libre open source projects. They develop in C, C++, Java, JavaScript, and Python. So, together with these developers, we discussed dependency management process from every possible angle. And today, based on these interviews, I will share with you our observations on the following aspects: selection of new dependencies, updating of existing, already used dependencies, automating dependency management or usage of dependency management tools, mitigation of vulnerabilities when no fix available. And well, let me start with the first aspect, selection of new dependencies. The most interesting observation about it, that selection of new dependencies is not an easy task. Developers have to check various sources and combine different kinds of information to understand whether they want to include a particular library to their project or not. This task requires time and experience. In large enterprises, at least, there exist specific departments and specific people who do this job. They pre-select dependencies and put them into a pool of pre-approved libraries. So the developers of such companies are safe to use any library from the pre-approved list in their projects. If a developer needs some particular functionality, she can ask for a new library to be checked, and after clearing, this library would be included in the list of pre-approved libraries. Well, if not cleared, an alternative will be suggested. For smaller companies, SMEs, such approach is quite expensive. In the best case scenario, a team of people who perform selection transforms into a software architect or an experienced developer who selects libraries. Otherwise, developers just look at some metrics of a library. In general, they are looking for popularity and a good community support of a library. As these metrics would mean for them fast appearance of functionality and security fixes. And the developers will not remain alone with their problems. If something happens, they can ask the library maintainers and receive a fast response, a solution for their issues. You know, this description reminds me of a formulation of a dynamic programming problem. Indeed, we have a lot of repeated actions. Developers look for exactly the same information for the same libraries. They Google library name, check its discussions at Stack Overflow, check Codex repository of this library, check number of stars, forks, project contributors. Maybe they also check number of open issues if the project is stored on GitHub. All this to decide whether the library is good enough to be included. So what would be the solution to optimize this process? For me, the solution would be to cache the repeated work, or like we call it in dynamic programming, memoization. So there is a need to combine this kind of information together and present it in the form of meta-metrics that shows the library is well supported, mature, and not affected by security vulnerabilities. In a form, this is used in large enterprises when they have a pool of pre-approved libraries. But this feature is also much requested by other developers. Okay, so what about already selected and used libraries? Here there are two major issues: awareness and lack of resources to control dependencies. In large enterprises, there might be a bit more resources, or they might have a policy, something like fix all issues before going to production. So developers have to fix issues in software dependencies if there are any. In smaller companies or for individual developers, the resources are more limited. Hence, developers prefer to postpone updates because they do not want to break their projects in case there would be some breaking changes in the dependencies. The interesting observation about security here, that many developers reported that security fixes for good, well-supported, popular libraries typically do not introduce any breaking changes. Also, these fixes, they kind of appear fast. So vulnerabilities motivate for updating if they are severe, widely known, and fixed versions are easy to adopt. So what's the implication here? Separation between functionality and security is necessary. Ideally, a developer should be able to see, okay, this version has functionality changes, and this version only security changes. In this way, she could plan the update. If she sees a new dependency version with only security changes, then she can plan to adopt it fast. For functionality changes, she can decide whether she needs such functionality and plan its adoption. Then, on top of this, there should be a direct indication whether there are any breaking changes done to the dependency. So, vulnerability fixes should be well indicated, free from breaking changes, and free from functionality improvements. Okay, going to automating. As I mentioned, developers lack awareness of existence of issues in dependencies and lack resources to cope with these issues. In theory, automated dependency management tools are there to help developers. However, the major observation is that developers do not trust these tools. They do not allow tools to perform sensitive tasks, like, for example, update of software dependency. So the tools, if used, only facilitate finding vulnerabilities that affect software dependencies of their projects. However, if a tool produces too many false positives or low priority alerts, and I heard several developers telling me this, so developers just decide to ignore such tools. They perceive this alert as spam and switch to social channels of their dependencies. So the developers say, well, if there is a new version or a significant event that I can just discover it from the social channel. So the implications for tool developers, dependency analysis tools should, first, generate only relevant alerts. So these alerts are not perceived by developers as spam, very importantly. Second, dependency analysis tools should show the affected components of the dependent projects. So developers could immediately decide how severe is the impact. For example, whether a core component is affected or not. Finally, dependency analysis tools should suggest a fixed version and if its adoption introduces breaking changes. So developers could estimate the cost of a fix and plan it properly. Unfortunately, not all security fixes appear fast, and there could be cases when there is no fixed version of a dependency available. So how do developers mitigate such scenarios? First, they try to assess if vulnerability impacts them, their projects, their customers. If not, for example, if a project only used for internal reasons, developers might decide not to do anything and just wait for the fixed version or community workaround. If the vulnerability affects their projects and especially their customers, developers check if there is any activity going around the vulnerability. If developers see that security fix is expected to appear fast, they might decide to apply a temporary solution, like disable affected functionality of their project or roll back to previous safe dependency version. Well, if the fix is not going to appear fast, then developers might decide to switch to another library. Several experienced developers reported that they do not wait for others to fix the issues. So they go directly to dependency projects, fork it, fix it, and create pull requests to make the fix available for the community. Several developers from large enterprises told me that they actually do this on a regular basis and even push project maintainers to accept pull requests and release new fixed versions faster. So, how dependency analysis tools could support developers in such a situation? First, they could determine part of the analyzed project affected by the vulnerability. So developers could quickly disable it. Second, dependency analysis tools can facilitate access to the dependency source code. So skilled developers could go and fix the vulnerability directly. The tools also can suggest an alternative library and ideally estimate the amount of changes necessary to switch to this library. So developers can have a plan B. Well, and at this point, we actually end our journey. So we reached the peak. Congratulations. And so let me just wrap up with the main takeaways of my talk. So for every developer who uses dependencies, security of project dependencies is really, really important. Second, for every developer who creates libraries, to get more adoption of your libraries, security and functionality should not be mixed. And lastly, for every dependency tool creator, developers are aware about your tool, but currently existing tools require fine-tuning to satisfy developers' needs. So today, we learned how to make dependencies secure. And I can't wait to share more in our upcoming Q&A discussion. Thanks for being with me.
Thanks very much, Ivan. That was a great hike. I enjoyed it. So yeah, thanks for taking us through that. It was, really, your research shows how hard it is to keep up to date with dependencies. Security is just, too hard. It's really, really tricky to do as a developer. But it's also good because quite a lot of the recommendations seem to, sort of help. The GitHub Advanced Security features that Gray and Pavel were showing us earlier definitely seem to adhere to a lot of your research recommendations. So yeah, I'm thrilled about this. It's great, but dependencies are scary anyway. So yeah, Dana, what about you? What did you think of the session?
I just think it's fascinating, like how we take for granted all of the nuances we have when we write code, and especially when you have monolith or monolith application, there's just so many dependencies. You're like library after library after library, and then we go into these new architectures where it's a slight shift, but then you have services compounded with new dependencies that have new libraries and packages. And so it's just awesome that we're focusing on there and trying to bring down that fear, because it is scary. You don't want to be the person making a breaking change. You don't want to be the person that's like, oh no, like I missed this in my dependency tree. And so it's just fascinating, the research that's happening here. But I want to kick it over to some questions that we have coming in. So as we've been saying, if you want to ask something right now, we're taking them live. You can go over to githubsatellite.com/discussions, and me and Martin will be queuing them up. But we got one right now coming from, all right. Not Tanny wants to know, are there any tools for doing, I think I got the wrong Q&As, Martin. Oh, no, this is the right one. Good. Not Tanny wants to not Tanny wants to know, are there any tools for doing the packages eval metrics that you can recommend? So they want to know, utilizing your research, like what tools would you recommend to go and find those dependencies, besides GitHub, of course?
Okay, great question. Yeah, I mean, definitely. So if you're using GitHub for storing and maintaining your projects, well, GitHub provides a very good service for that. But besides of these, so just for your tools, there are several tools available. Like for example, Sneak is a great tool, and well, it provides some good functionality. Then I think it also provides a lot of functionality for free, so you can just try it. Then there are some more tools which are paid, like for example, SourceClear. But yeah, I mean, personally, I have not used it, but people say it's great. Yeah. What I think are good and what is used, that, for example, and I think that's really great what the NPM guys are doing. So they just integrated the dependency analysis tool in the NPM ecosystem. And so you can just type npm audit, and you already receive some analysis of dependencies in your JavaScript project. So I think that's fantastic. Yeah. So.
That's fantastic. Yeah. So we've got another question here from, oh, I like this, Dana. You let me pronounce the hard usernames. Brilliant. Well done. So from Nazif Tiazoa. Oh, I think, sorry about that for butchering your handle again. How do developers, in your research, usually investigate if a vulnerability in a dependency affects their project or not? Assuming that such investigation will influence a developer's decision on updating that, if the vulnerability. How do they usually research that?
So well, so if I understand the question correctly, so basically I heard the two stories. This depends on the type of the let's say the vulnerability discovered. So if there is a fixed version for this vulnerability, then typically, and the library is kind of good and well supported, so then typically there is some so developers kind of. Okay, so how can I frame it? Well, okay, so sorry for this introduction, but yeah. So developers, yes. So developers basically they sometimes just know that, okay, they're using these dependencies, right? But typically this is kind of the first layer of dependencies. like what is they directly configure from their projects. And so for these dependencies, they typically just they keep it in mind that they use this dependency, and then they kind of read somewhere, I don't know, in some social media, in Twitter or in somewhere, that okay, there's a problem with this dependency. And this problem is like, if it's discussed a lot, so they start to see, okay, maybe I should also kind of update it. But and that's the most common practice that I heard. That's what they do. But actually nowadays, the situation is much worse, because we have a lot of like transitive dependencies that are hidden, and sometimes as a developer you don't even know that you're kind of dependent on this library. And so even if vulnerability like occurred there, then the only way for you to know about it is just to use the dependency manager tool, dependency analysis tool. So this dependency analysis tool kind of alerts you, and so then you start to see that okay, you also have this problem. And so these situations are much more complicated. And for this, what developers told me, what they do, they either try to kind of so they kind of they can bring the dependency like to the top level first, and so to make it manageable, or they I need a blackboard to tell about this, because it's quite difficult to describe it, just
it's hard. It's hard to stuff, man. I totally feel you. We used to work off our hearts, right? Like you didn't have the visibility into your code, and now there's all these amazing tool sets, so you can monitor in real time. You can understand your dependencies before you ship. You can get automatic remediation of vulnerabilities. I'm going to tell you, GitHub, I think, was it last year at Satellite or Universe, we released Dependabot, and that thing has saved my ass so many times because dependencies are hard. They're so hard. Oh,
yes,
no.
exactly. And I mean, this automatic solution, they are really, really helpful. I mean, this is a breath of air, and I mean, this is fantastic that we have them. That's true.
Yeah. But, because I'm not going to just let Martin have all the hard names. Okay, I am. Because you know what? Being a new Texican, I can't pronounce anything. I don't know why they let me do this at all. I just make up my own words. So Jamie Sloan, that's right. I took the easy one at Jamie Sloan. Watch it be Sloamy. Jamie, if it's Sloamy or Sloan, you know what? I love you. Much love. They want to know, open source software gives us the benefits of collaboration, quick delivery. So developing ways we can stay secure while not losing that is the way to go. They agree. So what about crowdsourcing these fixes that y'all are finding and delivering them to the line? They want to know, like, how can we apply this research and tool set that y'all are utilizing and give it back to the community?
I think that's a great idea. And I would be really happy if this would be actually possible to do it. But I think in a way, open source allows us to perform this, because I mean, dependencies are typically open source, and so anyone can just go and fix it. The problem here that vulnerability is vulnerability fixes might be a bit more difficult to implement, and they require some expertise to create a fix. At least that's what developers told me. So because if you do not fix it correctly, then everyone is just thinks that okay, it's fixed, so it's safe and they can use it. And but if it's not, then it's a problem. So so there should be some way how to basically control the quality of such fixes.
Yeah,
that's what I think.
And we had another question from HexRX. HexRX was asking, do you think unit test coverage is a significant metric? By the way, I've got some research I'm gonna throw back at you with this one. But go on, what do you think, Ivan?
Okay. Actually, I also participated to one of the researches where we tried actually to look if we can write some tests to execute some of the vulnerabilities. And in our research, we discovered that it's not always possible to just fire all of them. this is called reachability analysis, and so sometimes you can just find that there is a connection like statically, but then you can also try to run some unit tests, and this would be the dynamic analysis, and that will, if it can trigger the vulnerability, then it's for sure executable. But if not, then but if there is still this connection that is reported by static analysis, then it still should be kind of fixed. So answering the question, yes, the dynamic analysis, so it's the unit testing, it can help you find vulnerability, and if unit testing reports you something, then it's for sure you need to fix it. But for the other part, so here I would say that you need to combine the two things. So you need to combine the unit tests with also some static solutions, like with reachability analysis and so on.
Got it. That's fantastic. Yeah, I'll send out a tweet to a research paper I read a while ago. So at Martin Woodward on Twitter, if you want to get that. But it basically linked not test coverage to the biggest source of issues and things like that. It wasn't, static code analysis errors or some of these sorts of things. Actually, the metric that most accurately predicted where errors were going to occur was organizational complexity. So how crazy is your org chart? And it's amazing how much, problems that come about in software development are actually because of the people, the wetware, rather than, getting above 80% on your test coverage or whatever. So anyway, right. Well, Ivan, that was a great session. So thank you very much for your time. We really appreciated that. So speak to you later. It's going to be in Q&A if you want to get in contact. So see you later on. Thank you, Ivan.
Thank you. Bye, and see you in Q&As.